Today we're going to skip up to chapter 7 and do some integration by partial fractions because that's going to be helpful to us in the next section. I'm kind of surprised in how this book orders this, but I think knowing integration by partial fractions is going to help us with our logistic growth function in section 5.4. So this is actually hopefully a review section for you guys. For partial fractions, I'd maybe teach it a little bit differently than you've seen. So as long as you know how to get your A and your B for decomposition, that's fine with me. So our first example, partial fraction decomposition. What we're trying to do here, just as a reminder, is we're trying to split this up into two fractions. So remember that I have that is my factoring. So what I need to split this, what I want to split this up into is x plus 2 x minus 2. And so what I need is I need these coefficients. And I don't want them to be the same coefficient. I don't know what I was thinking there. Typically I use A and B. So how you can look at this, or how I look at it, is I'm trying to get from this side, this right side, to the left side. So I need to multiply this fraction here by x minus 2 over x minus 2. And I need to multiply this fraction by x plus 2 over x plus 2. The reason I think about it that way, I think is because I teach Algebra 2 trig. So I end up with this. I'm trying to get to this fraction, and I have a times x minus 2 over my common denominator So really what I need is I need the numerators to be equal. So what I need is I need a times x minus 2 plus b to be x plus 2 to equal 1. So what I do is I say let x equal 2. Because if x equals 2, this a term goes away, and I get 4b equals 1, so b is equal to 1/4. If I let x equal -2, what I'm doing is I'm letting x be these numbers that make this term go away. So if I let this term go away, we have a times x minus 2 equal to 1. But what I'm doing is I want x to be -2. So I'm going to plug in -2 there. I'm sorry, guys. I'm thinking about something else. My brain is somewhere else again. If I plug in -2, here I get -4a. There it's 0. So now a equals -1/4. So splitting this up into two fractions, I have a is -1/4 x plus 2 plus b. Oh, I can't focus today. I am so sorry. Plus 1/4, that's my b, x minus 2. And just so you know, if you actually go through and combine these, you should get this. Now, why do I care? Why do I care? Because now I can find the integral of this. So now I can split this up into -1, where'd it go? -1/4 x plus 2 plus 1/4 x minus 2 dx. I'm going to go back and just make sure I have that right. I do. Okay, so now we integrate. Really, I can pull out a 1/4. So I can actually pull out a negative 1/4. So I get, actually no, I lied to you guys. I'm going to leave the 1/4 where it's at. I'm still gonna factor it out. But what I'm actually gonna do, since this term is negative, I'm gonna flip the location. So I'm gonna put this guy here. You'll see why in a minute. I promise I know what I'm doing. Hopefully you'll understand why in a minute. Now what I do is I integrate. This is the ln of that minus the ln of that, of the denominator I should say, instead of saying that. Really, those are u substitutions. If you need to do those u substitutions, you can. Plus c. Now, you can combine these under division. That's what I want. That's why I switched the location, so you could easily see that it was combining under division. I guess you could put the 1/4 up as an exponent, but typically this is what you're going to find is your answer on a lot of the problems. So now find the following, okay? So we need to find our A and our B. So remember, I'm going to do my work for that up here. A over x plus 5 plus B over x minus 2 is equal to x minus 9 over x plus 5 times x minus 2. So A times x minus 2 plus B times x plus 5 is equal to x minus 9. And I just thought about this. Remind me in class, guys. I know some other teachers have different ways of teaching this. Remind me, we'll go through those other ways in class. So if my way doesn't work for somebody, so you pick an x so that this goes to 0. So I let x equal 2. That goes to 0. So I have 7b is equal to negative 7. B is equal to negative 1. Then I let x equal negative 5. That one goes to 0. I have a negative 7a is equal to a negative 14. So a is equal to 2. So now I can integrate. So now I can integrate this as 2 over x plus 5 minus, because b is negative, 1 over x minus 2 dx. Antiderivative of that is 2 ln of x plus 5 minus the ln of x minus 2. Remembering your log rules, first this has to come up and become an exponent. Any term that's negative goes in the denominator. I forgot my plus c. Plus c. All right. Last example. So again, separating out your variables. Actually, what I want you guys to do, and if you're an active learner in these videos, you're going to actually do this. I want you to find the A and B. So right now, what I want you to do is I want you to pause the video. And I want you to actually show the work of x squared minus 9, and then separating that out. I'm going to factor it for us. Separate out and find your So you now actually stop the video and find those. Okay, I'm not going to go through that work. I'm more than willing to go through that with you during class. But find your A and your B. What I get for B is I get 3/2. For A, I get also 3/2. So now I can separate this integral out into, since 3/2 are in both, I'm going to factor out the 3/2 and just have a 1 over x minus 3 plus my b, which is 1 over x plus 3 dx. I integrate don't forget your plus c like I did. It's not in my notes, that's why. If you want to multiply those out, you can. You don't have to. I just want to show you what your answer would be. Okay, so that's integration by partial fractions.